Alrighty, welcome back to this lecture 13, exciting and lucky number 13. In this lecture, we are going to start to talk about packages. Packages are really nothing more than libraries of commonly used and used together routines. What's magic about packages is that they allow you to basically act as black boxes. That is, I'm going to expose some subroutines through that black box interface, but I'm going to hide much of the logic and complexity within that black box. Great for two reasons. One is if you've got business reasons you need to keep some secrets on, package is a good place to hide those secrets from the programming public. Second is everybody has to be a junior programmer at some point. You got to start somewhere. And that's normally not on the most complicated logic. In fact, most time when you're just starting out, you get the easiest projects. Well, a good way to make it easier for those junior programmers is to hide the most complicated logic inside a package and then just expose the easier routines to the public. Very common practice in both cases. All right, in this lecture 13, we are going to start looking at a package I put together for user management. Now, Oracle has, what do they call it? OAAMS or something like that, which is a package you can purchase for user management, which does a very elegant job. What's the problem? Not everybody can afford it, and very few people can. And as such, everybody ends up making their own package for user management. Create a user, change a password, send an email, you know all this stuff. So we're going to do that same sort of thing here inside this lecture and probably the next one as well, wherein we're going to discuss package fundamentals in general in this lecture and then dive deep into the contents of our user management package in the next lecture. Should be great fun. Let's jump on into the inside. Lecture 13 script.txt and SQL Developer will get you there, so we'll see you on the inside.
All right. As you can see, there's a little setup work for us here at the top of our script. So, as sys, please go ahead and grant the myNFL user execute pribs on the util smtp and the util tcp packages. As I mentioned previously, Oracle supplies we PLSQL coders with a bunch of predefined packages. In our case here, we're going to use the SMTP utility to send emails to users who have forgotten their password. That email is going to be sent to the mail server via TCP/IP protocol, thus the need for the util TCP package. Again, I didn't need to write these guys. I just went on Google and asked how to send an email with Oracle. Sure enough, Oracle has a very nice example in their docs and has already built the necessary functionality into these two packages. I just modify their example to fit my specific needs, and in 20 minutes, I'm sending emails. No reinventing the wheel. Okay, moving on. Now, as the myNFL user, we have a couple of schema modifications to make. We begin by dropping that old insert user trigger we created back in an earlier lecture. We'll put that same functionality into our create user function within the manage users package and keep all that stuff in one nice consolidated location. We also need a couple of new tables here to store information about our users' devices and security prompts, so please go ahead and create those guys too. Next, please check out this very clever way of copying a table structure without the associated rows. That where 1 equals 2 clause basically says, go ahead and give me the metadata, but leave that actual data rows behind. Leave that clause off and the rows come over too. By the way, When you do this kind of table creation, the constraints do not move over to the new table. Just an FYI, should you use this technique into the future, you need to follow up with some additional constraints. Here we don't really need any constraints on an audit table, so we're golden. Only thing left to do is update our audit table to include a default date indicating when any prior update was realized. All right, now we're ready to start discussing our user management package. Like all packages, our user management package is defined via two parts, the package signature and the package body. The package signature is the outward pointing part of our package. It's what other PLSQL and SQL programmers can see and use. The package signature will normally contain a set of externally exposed data structures through which our package will communicate data to the outside world, and a set of exposed functions and/or procedures. Optionally, a package signature may also contain package-specific exception definitions, but my experience is that's pretty rare. The package signature serves to define our package black box to the external calling world. Well, if the package signature serves as our package black box, then our package body serves as the black box's contents. Only the package author or authors know how that black box really operates inside. The package body will generally have additional local data structures, locally scoped subroutines, and then, of course, the definitions for each of the externally exposed subroutines. Note, to be in scope, the local data structures and locally scoped subroutines must be listed before the externally exposed subroutines which reference them. If externally exposed subroutine X calls locally defined data structure Y and locally scoped and not exposed subroutine Z, then the definitions for Y and Z must precede the definition for X in our package body. First time you mess that up, you'll get us out of scope error and won't be able to understand why. But then you'll finally figure it out because I just gave you that big hint. All right, that brings us to our package signature. We start out with our now familiar standard, create or replace package, followed by the package name and the keyword as, or of course is. We then define some externally exposed data structures. In particular, in this case, we define an array security prompts, which is made up of a corresponding user-defined record type. When creating a new user, this array can be used to pass in a set of new user security prompts. We conclude our externally exposed data structures by defining an array of varchars to be used to pass issues back to the calling routine should problems occur with the data. We then finish off our package signature by defining each of the externally exposed subroutines and their associated signatures. The package signature is ended with the keyword and of course, its associated package name. Okay, if you're following along a developer, please go ahead and copy that package signature definition into the work area now and run the associated script. The result should be a package definition, but no associated package body yet. We'll look at that guy next. All right, we now move on to defining our package body. Syntax here is exactly as you would have guessed. Create or replace package body, package name, and then the keyword as or is. Again, we begin by defining a local data structure. This time we cleverly create a data structure which parallels a row in the users table and call that structure this user. As you might guess, this user is going to be used to store information about any currently active user and make that information available to all the subroutines as required. It saves us passing around a whole bunch of parameters between all these local subroutines. Just set up a local structure and then point the local subroutine at that structure. Next, we define a whole bunch of locally scoped subroutines. These are subroutines used and shared by our exposed routines. What's the magic? If you have business logic you don't want exposed to the world, you put it in here in these locally scoped routines and then only allow access to them indirectly by the exposed black box routines. Similarly, you might have logic which is simply too complicated for the typical junior programmer, and you want to keep that out of their hands. You put it in here in these locally scoped routines and then only expose it indirectly by the signature. These are routines that run inside the back blocks. In our case, none of these are exactly top secret, but it makes for a real nice real-world example when we can hide the more complicated logic associated with things like calculating password strength or sending emails. Those are pieces of logic I would normally not want to put into a new programmer's hands. Better to have a more experienced programmer put those together and then black box them behind a more simple create user or change password routine. By the way, we'll examine all these routines in detail as we go a deeper dive on the logic behind our exposed routines, so stay tuned. And finally, down here near the bottom of this rather lengthy script, you'll find our publicly exposed routines. These routines were all previously defined within the package signature, and here they're being flushed out with their associated logic and flow. One thing I do want to mention about our publicly exposed routines, please check out the two occurrences here of the create user routine. We saw this originally up in the package signature. What's going on here? This is known as procedure overloading. The net is that these two procedures realize the exact same business function. That is, they use to create a new user. However, it is often the case that differing front-end programming tools have differing capabilities with respect to advanced data structures and things like that. As such, we build two variants of the procedure, one for more sophisticated programming languages which supports the more advanced data structures, and a second for the less sophisticated solutions. This procedure was overloaded. Multiple occurrences of the same routine which differ only as to their signatures. No, you cannot create multiple variations which share a common signature. They have to differ.
Okay, I think that is going to make a good place for us to stop this lecture and pick it up again in lecture 14. We'll not bother with a summary only halfway through, so we'll just summarize the whole mess at the end of lecture 14 or 15, in fact, if we need to go that far. But I think we'll finish this one up. We'll finish up packages in 14, I expect. So we'll see you then. Quick study of what we've just gone through, and please take a few minutes to review this rather lengthy piece of code prior to our next lecture, wherein we're going to take a deeper dive. All right, in the interim, you out there and have some fun, but learn something every day. It's what's important.